this is Ms. Moore. I'm going to quickly walk you through how to look at the periodic table. Okay, so this is the second big topic in this unit. So far, you understand that the periodic table is basically a big table that organizes all of the elements. So it turns out that really only about 13 of these elements had been identified by the 1700s. But as we discovered more and more of them, we realized we really needed to organize them in order to use them and understand them better. So from there, chemists began realizing that they had repetitive properties. And so they started putting these into groups. As early as 1829, they were arranged into what were called triads, or groups of three that had similar properties. But groups of three triads weren't very effective, so we moved on in the mid 1800s to having about 70 known elements at this point. So Dmitry Mendeleev, a Russian chemist and teacher, began organizing the elements into the order of increasing atomic mass. And this was our very first periodic table. And his periodic table was pretty good. He had predicted elements that weren't even discovered at that time. But the issue with his periodic table is there were a few issues. So he left a lot blank because he knew they were going to be discovered, and he even predicted their properties. He had really good predictions, but there were problems with cobalt and nickel, and argon and potassium, and selenium and iodine. All three of these pairs seemed to be out of place. Cobalt did not have the same properties as the group it was with, and argon also, which is a noble gas we know now, didn't act like the alkali metals, which potassium did. So they just appeared to be out of place. So after that, Henry Moseley in 1913 came along as a British physicist, and he arranged it according to atomic number. And this actually fixed all of those problems that Dmitry Mendeleev had. And it actually is still the arrangement we use today. So this is the one you see up on the wall in your chemistry classroom every day. So this is what that looks like. We still have the 2 towers over on the left and the 6 towers over on the right. And you have the transition metals there in the center. And then your lactanides and antidides down there at the bottom. Those are also collectively known as the rare earth metals or the intertransition metals. So this is the periodic table we use today. At one point, it was proposed to use this crazy looking spiral periodic table. It is still following periodic law, meaning they are actually still grouped based on common properties, but obviously this wasn't very productive. So next, some things you kind of need to understand about the periodic table. So the periodic table is arranged so that it's increasing atomic number, but when we do it this way, when Henry Moseley did it this way, we found there was periodic repetition of the chemical and physical properties. And so if you're looking at the periods from left to right, those are horizontal, whereas if you're looking for groups up and down, the groups vertical are the ones that have similar chemical and physical properties, okay? And we often identify these by saying group 1A, or we use it with Roman numerals, so IA or IIA, and this is how we often talk about these. So what this means is if it's in the same group or column, it's going to have the same kind of chemical properties, so the same way that it reacts with things. It's also often going to look the same. It's going to have the same kind of physical properties as well. So there are 3 major areas of the periodic table. We have metals, nonmetals, and metalloids. Metals are things you think of that are electrical conductors. They have luster, meaning they're kind of shiny. They're ductile, meaning you can pull them out into wire, or they're pretty malleable. Think of aluminum foil. Nonmetals, however, are generally a little bit more brittle. They are not usually very lustrous or shiny. They do not typically conduct heat or electricity. Metalloids, on the other hand, are a little bit in between. This is the stair-step line. So if you're looking at the periodic table, right along that stair-step line between boron and aluminum, and it stair-steps down, are where you're going to find the metalloids. And these have properties just between. So they have some properties that are like metals and some properties that are like non-metals. All right. So just a quick recap: when you're looking at the periodic table and looking at a specific element, it displays the symbol and the name along with other information like the atomic number and atomic mass. Also, for the most part, if you're looking at a periodic table in the chemistry classroom, if the symbol is black and solid, it is going to be a solid at room temperature. If it is red, it is often a gas at room temperature. And if it's blue, it's a liquid at room temperature. If it's outlined, this means it is man-made. So taking a look here, we see this is a typical periodic table square. We see up here at the top is our atomic number. Here is our symbol, the element name, and then the average atomic mass, or the atomic mass, which you often use in grams to moles and moles to grams. Okay, so hopefully this video has helped you kind of recap how to use your periodic table and just looking over the overview of the periodic table.